Okay, that translation sheet that I gave you, and in the textbook, in the beginning of the section, there's a nice little table there with hints. You will be translating words into, get this, algebraic expressions, and later on equations. So you're going to take these words, you're going to substitute the words with symbols and express it. Okay? So here's the way I like to do it. And I used to write right in my book because word problems used to freak me out. So I don't know about you, but I would write right in the book. I would put my symbols with what I'm working with. How do you write -8? Can you write it like -8? How do you say plus using a symbol?
Positive.
How do we say a number if we don't know what it is? We need a variable. So when we have a mysterious, I don't know what it is, we call it a variable. You can choose any letter that you want. It just so happens that X is the most popular. You can use N for number. You can use, T for trouble, whatever you like. I typically will use X. So now all I have to do is put this together in a little expression. -8 plus X. That's all you're doing in the translation section. You're just taking an expression written out in word form and rewriting it using mathematical symbols and expressions. Now that was a simple one. Is that okay? Was that a question for me? Or no? Okay. I'll ignore you. I'll do my best. Okay, now we've got 76. A number subtracted from 12.
Your A's look like
X
two.
minus 12.
My A's look like something like 2s. Sorry. You're right. I was trying to be fancy.
X minus 12.
X minus 12. That's one try. I have 12 minus X. Anybody else want to offer anything? We don't have a whole other options here. Not too many. Anything else? Okay, let's look at it then. A number, how do we say that in algebraic terms? X subtracted from, what does that mean?
12 minus.
Yes, and how do you say that? How do you express that mathematically? If we're taking X out of 12, remember my little illustration of directions? From my house to your house, I start where? I start at 12. So this number is coming out of 12, right? So guess what I have to do? I have to write it almost opposite from the way it's expressed here. And that's only because of that word right there, from. When you see the word from, you gotta have it before you can take away from it, right? If I give you $5, guess what I gotta have?
Start at 5.
I better have at least $5 if I'm gonna give it to you. So you gotta have it before you take from it. So we gotta have 12 before we take a number from it. So when you see from, that should be a little red flag. Hey, pay attention to me, I'm not as simple as all the others. So we've got 12 minus X. This is gonna be our answer. This is a very, very common mistake with these. And it does matter because when you're dealing with negatives, you know how negatives can throw the whole thing off. All right, let's do 80. The quotient of -6 and a number. What's a quotient? It is division. How can I write that algebraically? How do you write a quotient?
Some number over a number.
Good. A number over a number or a fraction. Okay? Got someone working it out on the board already. The quotient quotient of -6 and a number.
6 over a number.
All right. So our quotient we can set up already as this over that, right? There's my symbol. And because of the way it's written in order for us. The quotient of -6. So where do you think the -6 goes?
Up top.
Up top. Top to bottom. And a number.
Variable.
Did everybody get that? Working it on their own? Any questions about that?
Is it always gonna be like that? Like the first number that comes up, that's gonna be on top?
For quotient, they will give you quotient in order. If the numbers are positive all the time, then order won't matter, because negatives are no big deal, right? No, if everything's positive, order's not gonna matter so much. If you've got a subtraction, that's where you really, really gotta pay attention to where those negatives go. Because if you had just 12 and x, would order matter? If it were 12 plus x, isn't that the same as x plus 12? All day, every day.
Now, I was just
Sure
talking
is.
about the quotient, you know how it's -6 over x?
Yep,
Is it always
it
gonna
will
be
give
like
you
that?
top to bottom, yep. If this said the quotient of a number and -6, what would go up top? The x, the number, yep. Top to bottom for quotient. Okay, so, I want you to try on your boards number 84. It is twice a number decreased by 30. And yes, you can use your little cheat sheet that I gave you for now.
What was it? Twice a number.
Decrease by?
Yes. Twice a number decreased by 30. Ooh, where'd you get that term?
What is the number?
Not quite. Okay, that's not bad. Good, good, good. What's that? Good, good. Good. Nicely done. Like rapid fire, these boards are flying in the air. I love that. Okay, so if it's twice a number, decreased by 30.
That's multiplication.
Is this subtracted from, is this the same thing as saying subtracted from?
No.
Not in verbiage, but in the thought process, because you are decreasing something. And decreasing means what operation? Subtraction. And when we got subtraction, we got to pay really, really close attention to what's being subtracted from what. But this one's put together a little nicer, I think. So how do you say twice a number? I saw some of this. Honey, we're not doing that right now. That means something else. What does that mean?
Sorry, this is the second power.
To the second power, yeah, or squared. Okay, 2x decreased by 30. Where does the 30 go, front or back?
Better.
What sign do I use?
Negative.
What operation?
Subtraction.
Because the 2 times the number is having 30 taken out of it. It's being decreased by 30, yes.
And can you explain why it wouldn't be 2 parentheses x minus 30?
Like this?
Yeah.
That's a good question.
Because you
those
can
are
also
kind of-
read it as a number decreased by 30 times 2,
Is that the same as this?
pretty much.
No.
Is pretty much okay in math? Never. Yeah, because what we have going on here is just exactly what you said. This is 2 times the difference of a number and 30. That's what this sentence says, which you will get.
But isn't
What are we finding the difference of?
X and 30.
What are we finding the difference of here?
I got you.
Nice. Light bulb! Any other questions like that? And that was a nice segue into what we're doing next. Yes?
I did it like this. Does it make a difference?
That's fine. What she's saying is she wrote it like this. That's fine because you're still expressing 2 times x. It's just that you won't see it that way. So if you were to check the back of the book on that homework problem and it wasn't written like that, you might think, oh my gosh, what did I do wrong? And then you start manipulating and changing and trying to come up with what the back of the book says. It's just that we don't really use that very often. Now when we use substitution values, yes. Remember when we were saying, take this expression, simplify it, x is equal to -1, then we would definitely use those. But if you wrote it like this, you can simplify it. Get rid of those little bracket things. Any other questions for that? Pretty confident with those? Yes? Ready to go on to the next section? The word problems in the next section? I'm assuming yes, there's no other questions. All right, the last part of 3.3 in translating, the only difference here is you're writing the sentences completely. You're solving, but they're being nice. They're not giving you these unknowns. They're giving you numbers for this little section here. So like for instance, on page 189, number 65. In words, it says, the sum of -42 and 16 is. On my cheat sheet, what's the symbol for is?
Equal.
You see how equals is expressed in many different ways? Is one of them. So you would write this little sentence in this section as -42 plus 16 is, what was that last little one? -26? All you're doing is expressing it the way that it's asking you to. There's no unknowns here. So it said the sum of, and what's sum?
Addition.
There's our addition right there. Of, and then they gave it to you in order. -42 and 16 is -26. Is that a true statement? How can you check that?
Subtract.
-42 plus 16.
Which is what? Does -26 equal -26?
Yes.
Then that's a true statement. You weren't lied to just now. That's all we did. Remember when we were doing that before and we were checking for true statements? That's what this is. It's just translating these sentences into algebraic or mathematical expressions. Any questions on those? All right, try one on your own. I want you to do number 67, and that is right from your homework. So if you've done the homework, you've already done this one. Number 67 says the product of -5 and -29 gives 145. Nice. Do that on your board, nice and big for me because I have a little ice. Nice. Good. Good. Did anyone check and see if it's a true statement? Or are you assuming you're not being lied to? Good.
This book is never wrong.
We discussed that already. Good. Nicely done. She's shocked. Okay, so what operation is product? It is multiplication. And then it gives you -5 and -29, and it says it's positive 145, I think, if I recall correctly. So product is multiplication. So these little parts of the homework is going to rely on you being able to translate the terms into symbols and mathematical operations. Okay?